new face recognition software was tested for accuracy with 1,000 images of people. Each test consisted in showing 2 pictures of people's faces and deciding whether it was the same person or not. For what percent of the tests was the software accurate? That is, positive for the images of the same person and negative for the images of different persons. Okay, now here the total number of tests are divided in 2 categories. Okay. One category is the response from the software, which is called positive and negative. And the other category is what's really happening. They are giving you the same picture or different pictures. I mean, same persons or different persons. Now, the question is, for what tests was the software accurate? That is, positive for the same and negative for different. We want the sum of these two squares. Statement number 1 says, of the tests that resulted in positive, so only of P, 10% consisted of images of different persons. Okay, let's just call this P. 10% is in D. 10% of P is in D. Therefore, 90% of P is in the same. Okay. Now, statement number 2 says, of the test that resulted in negative, 90% consisted of images of different persons. So again, of negative of N, 90% consisted of images of different persons, that is here. 90% of N and 10% of N. Now, each statement alone is not sufficient because each one is giving you one piece of what they're asking you. Okay. Now, do we need to know the value of P and N? No, because what they're asking us is the percent of the total number of tests that are accurate. And if I add them up, they have the same coefficient, which is 90% of P plus N. And P plus N is the total, right? Therefore, I can answer that 90% of the total tests were accurate. Therefore, I can answer that the answer is unique, and the answer is C.